Hi everyone, welcome to today's Earth Science video. In this video, we are going to be learning about convergent plate boundaries. Okay, you may remember that there are three different types of plate boundaries, or three different ways that two of Earth's plates interact when they meet. Okay, when two plates are interacting at the Earth's surface, there are three different types of plate boundaries, or ways that they interact. And in today's video, we are learning about convergent plate boundaries. So in a convergent plate boundary, okay, the two plates of Earth's crust are moving toward each other. Okay, I want you to think of the word converge. Converge means to come together. Okay, a congregation of people. When people congregate, they come together. Okay, earlier in the year, we talked about converging winds, winds that blow toward each other. Here, as you can see in these diagrams, the arrows show that the two plates are moving toward each other. They're coming in the same direction. Okay, this diagram here also shows us a convergent boundary. We have the arrows showing us which way each of the plates is moving, and here we can see that the plates are coming toward each other. Okay, this convergent boundary has two pieces of continental crust coming toward each other. And what happens when two pieces of continental crust come towards each other? Well, that's when we get mountains, okay? So when two continental plates come toward each other, we get mountains. And the more those two plates move toward each other, the bigger and bigger the mountains get. For example, Mount Everest, which is the tallest mountain on planet Earth, is growing each year. It's getting bigger and bigger each year because it's a convergent plate boundary. The two plates are coming toward each other and they just push each other up. The mountain gets higher and higher each year. Another type of convergent boundary, okay, is when you have a continental plate and an oceanic plate come toward each other. Again, our arrows still show that the plates are coming toward each other. But this time, okay, instead of pushing toward each other and moving up and getting higher like the mountain, the oceanic plate just moves underneath the continental plate. Okay, and that piece of Earth's crust goes back into the earth and melts back into magma. Usually around these areas, we have a lot of volcanoes, as we can see in this picture. Okay, but the thing to know here is that this type of boundary is called a trench, because typically what we see is when this oceanic plate moves underneath the continental plate, it creates a very, very, very deep hole, or a very deep trench in the ocean floor. That's some of the deepest places. Some of the deepest places on the ocean floor are near convergent boundaries where there is a trench. So let's go back to our notes diagram that we're working on this week. Okay. And for this video, we are going to work on filling in the convergent boundary row. Okay, so in a convergent boundary, let's fill this in. We would say that the plates are moving toward each other. Oops. Okay. What does it create? Well, it can create three types of features on Earth's surface. Okay, one of them is a trench, like we just mentioned, a deep sea trench. Another feature is a mountain range. And another thing it could create is what's called an island arc. Our diagram of convergent boundaries should have two plates moving toward each other. Okay, and you can have one going underneath the other. But the most important part is to have those two arrows going toward each other. Let's go ahead and look at ESERT page 5, okay? And today in this video, we will go over the convergent plate boundaries on this map. So if you don't have your ESERT out, please go ahead and take it out. Today we're looking for the convergent plate boundaries. If you were able to highlight or color over your ESERT yesterday, try to find a different color highlighter or colored pencil. That way we can add it all up and have a few different colors highlighting the 3 different types of boundaries. So for today, I'm going to use an orange highlighter. I'm going to look at the key at the bottom first, and I want to find where it says convergent plate boundary. Okay, convergent plate boundary. Above that, it shows me the symbol for convergent plate boundary. The symbol for convergent plate boundary has 2 arrows pointing toward each other, and it has this line that looks like it has little Lego blocks sitting on top of it. Let's go ahead and find a convergent plate boundary on this map. Let's start up by Alaska, right up here. Okay, I can see I have the 2 arrows pointing at each other, and it has the line with the little Lego-looking blocks. Just like we learned with the convergent boundary, the divergent boundary has the symbol, and then it gives you the name of the boundary. Here, this is called the Aleutian Trench. Remember, we just said that one type of convergent boundary is a trench. Okay, let's go ahead and keep highlighting the convergent boundaries on our map. Okay, over here, this is all a convergent boundary. Here, we just highlighted what is called the Mariana Trench. Some of you may have heard of this before. This is one of the deepest parts of the ocean floor. I can keep going all the way here. This is all still convergent boundary. We have that bold, dark line with the little Lego blocks on top. Sorry, I messed up a little bit there. Let's try that again. We'll go to here. There we go. The Tonga Trench. The name is right there. Okay. Let's keep going. We have more convergent boundary over this way. Okay. This part here that I just highlighted is a convergent boundary on land. Okay, this just happens to be where Mount Everest is. We have our 2 plates coming together, causing Mount Everest to get higher and higher each year. We have a little bit of convergent boundary over here. If I come back to South America, over here I have the Peru-Chile Trench, okay, which is off the coast of South America, and a little bit extending into Central America and Mexico, a little bit of convergent boundary in there as well. Okay, let's try one more practice question. If I were looking at the Peru-Chile trench here, let's try to think about which two plates are coming together at that area. Okay, which two plates are coming together? Well, on this side, I have the South American plate, and on this side, I have the Nazca plate. So the Peru-Chile trench here is when I have the South American plate and the Nazca plate moving toward each other, okay? The arrows would show that they're moving toward each other. And one plate is slipping underneath the other plate.